Netsparker, the developers of desktop and cloud-based web application security scanners that enable you to automatically identify vulnerabilities in your web applications and web services. Netsparker scanners employ a unique and dead-accurate vulnerability scanning engine that automatically verifies vulnerabilities with their proof of concept. For more information, visit them on the web at netsparker.com or email at contact@netsparker.com. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies. Protecting over 7,500 applications and 150 billion production requests per week, Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences' patented technology protects any application against any attack, with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at signalsciences.com/PSW. Welcome back, everyone, to Paul's Security Weekly. Funny story about our upcoming webcast. I did the prep call with them today, and the presenter's name is Brandon from Chronicle or Virus Total. And I was like, hey, Brandon, how's it going? I'm like, nice to meet you. He's like, we actually met a couple times. And I'm like, oh, wait, where did we meet? Now I look ridiculous. And it's like, oh, I presented with Allison Nixon at B-Sides, Rhode Island. Huh. I'm like, oh, you're the Brandon that presented with Allison Nixon. And so, I mean, if that doesn't give someone street cred, I don't know what does. So I was like, now I'm really looking forward to this webcast. And it actually showed me some of the slides. It's going to be fantastic. You can go to securityweekly.com/chronicle and register for that webcast today, right now. Do it now. Well, I mean, watch this technical segment and then do it maybe. So that'll be December 5th from 3 to 4 p.m. Eastern Time. Sven Morgenroth from Netsparker. First, want to encourage everyone to go to netsparker.com/securityweekly. Check out their awesome products. Sven, who is no stranger to the show, is here with us. Sven, welcome.
Thank you very much. Nice to be here.
Yes, nice to have you. And tonight we're going to be talking about PHP Object Injection vulnerabilities.
Exactly. They're quite common, actually. And they are very easy to exploit if you know how to do it. And I will show you today how it's done.
Sweet. Let's do it.
So I will share my screen with you now. And just a second. So can you see it?
I can, yes.
Okay, great. My talk is called PHP Object Injection, a wake-up call for those who use unserialize on user-controlled input. And first of all, let's talk about what objects actually are. And how to create them. So an object in PHP is an instance of a data structure that is defined by a class. And therefore, you usually create them by using the new keyword and a class name like so. Object variable equals new some class. And in order to create an empty object, you can use new standard class, or you can also cast an empty array to an object like shown here. Or you can just use JSON decode with an empty object. And there are probably other ways as well. So let's create a PHP object. Assume we have the following class. We have a class called dog. And you can pass it the color of the dog, color of its pattern, and the actual pattern. And it will, for example, if we say the brown dog has white dots, we can print it down here with this format string. So what does the corresponding object look like? We can use var dump to show its content. And if we use var dump new dog brown white spots, we will get this object here. First of all, we have the class name in there. We have the property name, in this case pattern color, and we have the property value. So what are objects used for? Common operations on objects are reading their public properties, like seen here, color equals dog, and this operator will just receive the color in this case. And you can also edit or create public properties, like dog shape equals round, and therefore dog ate too much equals true. So you can also call methods, like the dog describe method we've seen before. And there's a thing called magic methods as well. So objects are more powerful than they seem. Classes can define certain actions based on a variety of triggers. This is done by defining a magic method. Magic methods usually actually always start with 2 underscores. Some examples are toString, call, construct, destruct, sleep, and wake up. And for example, a method called toString is called whenever an object is casted to a string. Now let's look at that. Let's name our dog. So we extended the dog class, and it now has also a name that we can give the dog, and the toString method that will return the name, and the rest stayed the same. So if we want to print the dog's name, we can do something like this. Dog variable equals new dog with the name Buddy. He's brown and has white spots. Now we can just print this. First the describe method, and then we can use dog just in the string here. This would print this brown dog has white spots. His name is Buddy. So far so good. But what if you want to store an object somewhere and use it later? And there's a way to do this, but it's not very straightforward. As PHP objects are PHP-specific data structures, and as such, it's not possible to store them in a database or write them to a file. However, if you turn them into a string of a certain format, you can save them. You need a certain format in order to distinguish public, protected, and private properties. And you also need to have specific string representations for each of the data type that PHP has, so you can correctly reconstruct the object later. So in other words, you need the serialize function. Let's look at the serialize format and create an object that contains different data types. And then we can serialize it. So we have different data types, like true here, or a Boolean, or we have an integer, 1 to 3, a string, an array, associative array. And we have here the serialize function. So what this will print is this very confusing looking string. So let's analyze the format. A string produced by serialize contains all the required information to reconstruct an object. This is one example. So we have an object with a class name for a class which is called class name, and it has 2 properties. The first property is called first, and it has the value 1. The second property is called second, and it has the value 2. And whenever you use strings, you need to specify the length. This is done here. For example, class name has 9 letters, then you need to specify it here with the 9. First has 5 letters, then you need to specify it here, and so on. So this is what objects in PHP are, but what is the vulnerability here? So the problem are properties and magic methods, and in order to turn the string into an object, you need to call the unserialize function. So this function passes the string and turns it into an object, or any other specified data type or structure. You can also serialize strings, arrays, etc. So the problem is that you can't that you can't really save the state of such a class in some cases, because for example, if you have an open database connection, you can't just store this somewhere as a string. It just doesn't work. So you have the wake up method that you can define, that will in which you can create a new database connection or something like that, or other things that need to be done before you construct the object. So if it is defined, the wake up method, it is called whenever the string is deserialized, and that might lead to a vulnerability if any property is used in an insecure manner. That also affects other magic methods, not just wake up, but wake up is just the most convenient one, and it's easy to show. So let's see how it works. I've prepared a little web application right here. And okay, this is a little bit difficult. Okay. Okay, never mind. So we can register here. You can use a username. An email, password, and then we are logged in. So let me just see. Yeah, I can move this. So we have an example site. It doesn't have much content yet. It says this site is still under development, and once we're done, you'll find a lot more content here. However, what it has is this preferences. Can you hear me?
Yes. Yes.
Okay. So this is the here you can set some preferences. For example, you can activate the dark mode, and so this is actually saved up inside a cookie. If we look at this, it looks like this. This is actually a serialized array with 3 elements. It saves the currency, the language, and the V mode, which is the dark mode or light mode. And yeah, so it seems like you can pass such a string to within a cookie, and it will later be deserialized. And if we want to exploit this, we will most likely first look at a wake up method in some class. So it happens that this web application also has a logging class that writes logs to a file. And we can see down here that we have this code here inside the wake up magic method. And this looks pretty harmless, right? So it just will write the static string resuming log to a log file whenever it is deserialized. And however, if we look in the log status, we see that we have a property here, a public one that will contain the format string here, and we can actually change that if we deserialize an object, if we create one that we will later deserialize. And we also have a file path up here in the function, the right method, and this will just allow us to also change the file path. So basically, we can write a file anywhere on the system with content that we control. Let's just create an object that will abuse the fact that we can write a file like that. So we need to create an object, and it will need to have the name logging, because we are trying to deserialize the logging class. And this has, let me check, 7 characters. It also needs to have two properties. The first one is file path. Oh, no, let's start with status message format. So we first have to pass the variable name to it, which has 19 characters. And its value will be our payload. So let's just quickly write one. PHP system and just a directory listing. And this has, let me check, 26 characters. So we type that here. So this is basically our first property. And then we need to pass a file path as well, which is the path where our file will be written. I just do this new line because it's easier to see. It would just throw an error actually if we try to deserialize an object with a new line like that. So I have to change that later. So again, we need to pass the name of the property here. It's file path, and it has 8 characters. So we type that here. And now we can choose a path and a file name. So it will be in logs.php, which has, let me see, 14 characters. Okay, so what happens now if we copy this into our cookie is that it either will throw an error because I made a mistake, or it won't. So we'll find out in a minute. It seems like there wasn't an error, which is okay. Which is not surprising, I guess, because I didn't save it. Weird. Okay. Let's do this a little bit. Oh, wait. I need to check that. Okay. Yeah, I think it's just because I didn't encode it properly. So does that work? No. Okay, just a second. You're still there?
Yeah, I know you fix it. You always fix it, Sven. I swear
Okay.
you do this on purpose to kind of make us wonder if it's actually going to work, but I think you know it's going to work.
Yeah. Probably. So
We have faith. We have faith.
okay. So next try. This time it's actually encoded. Maybe this works now. Yes, it looks like it works. So what we
See, I
see
told
here is
you.
an error message that says cannot use object of type logging as array and blah blah blah. And that means that our class was deserialized correctly, or our string was deserialized correctly, or whatever. And we can check this by typing in logs and pound.php. So yes, it worked. So what this did was just creating a new file with this content here. I just did it twice because it somehow called the function twice. But that's basically how you exploit such a vulnerability. Now you may wonder what happens if the logging class wouldn't be in the scope of the file that uses the unserialized function. And more often than not, you have an autoloading function. It may look like this, though it's deliberately changed. So you probably, I don't know if you would see this in a real world application, but I was just using it to show you some trick that you can use with autoloading. And this would just would be called if no class with the name you were trying to access would exist. It would try to call this function, and then you can include a file here, and for example, include classes. And PHP would try to include that file, and if it doesn't find it, it would throw an error. But if it would find it, it would just include it.
Sven, does limiting the scope of your classes, does that help, or in PHP is that not as easy to do?
Can you repeat the question, please?
Is limiting the scope, because before you said earlier when you're calling that logging function rather, that it was likely in scope. In, you know, as a programmer, right, you can control which classes are in scope at certain times. Is that true?
Yeah, you can include them like that. But it doesn't. It would help probably if you don't have this autoloading functionality.
Okay.
But it's just very convenient, and you don't have to write these. However, I don't know, these probably dozens of classes on top of your files, so it's done automatically, which is quite convenient and often used.
Right. That convenience and usability is often what bites PHP in the butt when it comes to security.
Yeah, exactly.
Its downfall.
So you can abuse this too if you would create an object like this. So let me check. Okay. So you can use a class name like secret, and this is, let me check, 13 characters. And yeah, so we have a secret file here, and it's behind the HTXS. It's protected by HTXS, so you can't access it directly. And if you would now do this, what would happen would be that the secret /secret file wouldn't be the class wouldn't be found. So this is actually used for different namespaces. But it also doubles. It's convenient that you like the backslash is also a directory separator in Windows. And what happens here is that the class can't be found. Then autoload would kick in, and it would try to find this here, which is actually quite common to have something like this. This is not so common, but it will be used for demonstrating this problem. And after that failed, it would try to include the class name, which is secret, then the backslash and secret.php, which is actually this folder in this file. So let's try that. And let me check. I don't know. I need to encode it again with a double backslash, I suppose. So let's paste this here. Hope that it works. Yeah, so the file is included now. That's because of the auto-loading functionality. So you already, so it's I will not tell you a sentence that you don't hear very often. And this kind of vulnerability is not unique to PHP. The vulnerabilities that arise from deserialization can be found in many programming languages. They are in some aspects even worse than in PHP, which is also not that common. For example, in Python, you have Python's pick library that doesn't need any gadgets, just a reduce method. And so gadgets, if I didn't explain that earlier, are these existing code patterns like the wake up method and that stuff that you will abuse. And they will just do, you can just make a class with a reduce method and then serialize it, and the method contains the code that you want to execute. So it's pretty straightforward. Then there's also Ruby, which has gadgets in its standard libraries, so you don't need any existing Ruby code that was vulnerable. It's like vulnerable out of the box, basically.
Now, wait, I was going to say the next one has to be Java, right?
Exactly. Don't worry. So it has gadgets in commonly used libraries, and it's like you hear about Java deserialization.
And Sven, the gadgets are basically that auto-loading functionality of a class?
I guess you could say so, but I think it's you would more commonly refer to you would say that the wake up method, for example, is a gadget.
Okay.
Yeah. So let me just move this. You don't see it probably, but there's a bar that's really annoying and confusing.
Oh,
so
yeah, that's on your side. Yeah, you have some of the controls for Zoom.
Yeah, exactly. So, however, in some aspects, PHP is worse, of course.
Of course.
And unserialize is a common target for low-level stuff like memory corruption, etc., denial of service, info leaks, and code execution, which is probably not that common in other languages. At least I'm not aware of it. And the PHP documentation clearly states that you should not pass untrusted user input to unserialize, and that unserialization can result in code being loaded and executed to object instantiation and auto-loading, and a malicious user may be able to exploit this. So this is basically what we've seen now.
Yeah, like they know it's vulnerable. They put a warning in there, but yet I feel like there's things in the language could adopt to prevent something like this, but that would make it harder to use, going back to our earlier point.
Yeah, exactly. You also have this allowed classes parameter now. I don't know exactly how it's called, where I think you can whitelist certain classes in there, but it's still not seen as secure, and you should still not trust users to put data in there. And that's also why PHP developers don't even consider these low-level vulnerabilities and unserialized as security vulnerabilities anymore, because it's basically they basically already said that you shouldn't use it at all on user-controlled input, so they just treat it as a normal bug. And you may ask,
go back to that. So they treat it as a normal bug, even though in the documentation it says that essentially could lead to an exploitable condition. Yeah,
I mean that's how they explain why they treat it as a normal bug, because I think they want to say that we clearly stated in the documentation that you shouldn't use this on user input. So if you find something like a memory corruption or something in there, it's basically just like it shouldn't be reachable by a user anyway. So it's not a security vulnerability for us.
Interesting.
So they put they actually say that the vulnerability is if the developer uses this input and unserialize. So it's easy to prevent this actually. You don't pass user control input to unserialize to begin with. Like that's pretty easy, right? But you need an alternative. And often you can use JSON encode or JSON decode to do that. What you also can do is, if you really need to store it somewhere where a user could change it, like in a form field or something like that, you can use an HMAC, at least protected that way against users that try to mess with it. And that was the talk. So if you want to read more about PHP Object Injection, you can check out our blog post about it, and it goes into detail a little bit better than I just did. It also tells you how to deserialize an object with private properties or protected properties, something like that. So yeah, if you're interested in it, you can find it in the link.
Fantastic. Sven, thank you so much for appearing on Paul Security Weekly.
Blown away as
Thanks
usual.
for having me.
Absolutely.
Blown away as usual.
Thanks, Sven. With that, we're going to take a short break. Come back with the security news for this evening. Stay tuned.